Okay, so here's some other problems that we can use these trig identities to help solve. So if you look at this one, it is a sum, and so I want it to go into a product form. And so I'm going to use a formula like sine of alpha. Let me get my pen here. Sine, this is going to be my alpha and my beta. And so the formula for that, or trig identity for that, would be then 2 sine of alpha plus beta, which of course is 14, and then cosine of alpha minus beta, so 8 minus 6 is what, 2? And then divided by 2. And so to simplify that, I just get 2 sine of 7 degrees, these are in degrees, and then cosine of 1 degree. And again, those aren't on the unit circle or anything like that, so that's the best I can do. If I guess wanted a decimal value, you could type that in a calculator, but as far as simplifying using trig identities, that's it. All right, so here I have cosine minus cosine, so again, here's my alpha, here's my beta, and I'm going to again look at a trig identity to help me out here. This one has a -2 in the front, sine of, all right, now I need to add those fractions, so I need a common denominator here, so what is it, 40? So 8 pi over 40, just times 8 times 8, and then plus, let's see, times 5 times 5, 5 pi over 40. So that ends up being, what, 13 pi over 40 divided by 2. So I'm going to just write this 40, and then all of that is divided by 2. And then I end up, for my second part, sine of, and we need to subtract these. So I have 8 pi over 40 minus 5 pi over 40, which is what, 3 pi over 40, but again, that's going to be divided by 2. Okay, so again, remember when you divide complex fractions or divide fractions, you multiply by the reciprocal. All right, so I'm going to take 13 pi over 40, and this is really 2 over 1, so 1 over 2. So I get a -2 sine of, what is that, 13 pi over 80. All right, same thing over here. I'm going to take 3 pi over 40 and multiply by the reciprocal, because 2 is 2 over 1. And I'm going to get sine of 3 pi over 80. And that's it. Okay, so that formula has that negative in it, which in front, which the other ones don't have. All right, this next one. All right, so let's see here. I'm going to highlight this quick so we can focus on that one. So there's my previous questions here. All right, so let me grab my pen and get the ink thinner. All right, so here it's a subtraction of sine. So again, here's my alpha, here's my beta, and I just need to find the right trig identity to do there. And so I get 2 cosine, and then again alpha plus beta is 10t all over 2, and then this is sine here in this formula, and you subtract them and get 2t over 2. And again, I'm just going to simplify. So this is what, 5t, and this is sine of t. And again, that is my final answer, and I'm done with that one. All right, and then the last problem I have here is it says to write it as a sum. All right, so I'm giving you the sum of, here's alpha, or I'm sorry, I'm giving you the product, and I want you to write it as a sum. So here's your alpha, and here's your beta. So you have to go backwards, and well, I guess technically we can use the product to sum formula, so we don't have to go backwards. So we're going to go ahead and look at sine of alpha and beta and use one of those half formulas. So we get half, and then I get my bracket, and it's cosine, and I subtract alpha and beta, so that ends up being, what, 2 theta, and then it's minus cosine, and then I end up adding alpha and beta, which is 10 theta. And it says write as a sum. Basically, I would be okay if you left it like this. I guess if you wanted to distribute the half and write it a little bit more simplified, you could. All right, and then that's your final answer. So again, you're just using formulas to solve these problems.